G'day chemistry students and welcome to the Working Scientifically series. Now I thought that I'd make a few videos as we move through this course which are more focused on our skills and I guess less tied to any one particular module. So to begin with, something that we're going to be doing in our first experiment and for the rest of this course is continually come back and look at validity, reliability and accuracy. Now, this video in particular will be looking at first-hand investigations. So, I guess evaluating validity, reliability, and accuracy when you are completing experiments rather than undertaking research. Now, first off, let's look at validity. So, when we are describing whether or not an experiment is valid, what we're evaluating is the experimental design. So essentially, determining whether or not the design actually meets the aims of the experiment. Was the design of our experiment actually suitable? Um, Essentially, to be able to make that determination, we have to make sure that the test is fair. So in a lot of cases, we'll be evaluating whether or not we were able to control all of the additional variables that we were not supposed to change or measure, as they could potentially be influencing the integrity of our experiment and the suitability of our methods. Another way of evaluating validity is ensuring that our measurements that we take actually measure the variable that we intended to measure. So there's no point saying that we're going to measure a particular variable, but then found that when we were doing the experiment, the measurements that we took didn't actually measure what we intended. The next criteria that we can evaluate experiments on is reliability. Now, this is the evaluation of the consistency of the results. So essentially, what we're looking at is determining whether or not our observations or measurements are similar across multiple tests. Now, there may be a little bit of a misconception that you may have. It depends on what you were taught in earlier years, but there is a general misconception that repeating the experiment is our way to get reliability. But in fact, this doesn't actually guarantee our reliability. All it guarantees is that we were able to repeat our experiment. What we want to make sure that we're doing when we're repeating our experiment is ensuring that our results remain consistent between all of those tests. Essentially, repeating ensures that our result was not random or an outlier. So, for example, in this experiment here, what's been found is with lots and lots and lots of repetition that there's been an outlier within the test. If you are to only test once for or test your experiment once and undertake it once and only got this outlier on the top, then you would have no idea that this is actually an incorrect result and that the consistent set of results follow this trend or this pattern down the bottom. Now, to show reliability in a bit of a diagrammatic way, what we would say is that if I had a series of results that were all consistent and all really close to each other, they look like my series of dots on a target board that are colored in red, something like this. Now, these are all hitting about the same mark. It doesn't matter where on the board it is, but we are hitting the same mark on the target consistently. Thus, this would consider to be a reliable set of data. However, with my dots in green, what we can see is we're hitting in the same general area, but these dots really aren't consistent at all. And so what we would say is that these dots would be considered to be an unreliable set of data. Having a look at the next part, here we have accuracy, which is an evaluation of correctness of results. So once we've taken the results and we've looked at them, maybe we see that they're consistent. Are they actually correct, or is there maybe something wrong with the results that we have? So this can kind of get broken up into two parts. Um, the first is the precision of the measurement, which is technically a separate category, but within the scope of our course, we only look at validity, reliability, and accuracy. So precision kind of gets rolled in. So that really is how precise we are taking our measurements, what equipment we are using, and what techniques we are using to take measurements. So as an example, if we were trying to measure the length of the table but only had a meter rule, then our precision wouldn't be particularly precise. However, if we were to take measurements, say, in millimeters, then what we would have is a much more precise measure than a measurement that can only round to the nearest meter. Um, Generally, what we'll also be looking at as well when we're evaluating accuracy is making a comparison to literature data or expected results. Now, for us, we're not making any particularly new discoveries, so a lot of the time we'll be comparing to literature data, which essentially means that we are going to look at actual values, measured values that have been confirmed by many experiments, and seeing how our measurements stack up to those actual formal pieces of data. Now, if we were scientists making new discoveries, then usually when we do an experiment, we would first be doing some form of modeling or mathematic theory, calculation, etc., to determine what we expect the results to be. And then test those expected results against what we got in our experiment. And if they line up, generally what that means is there's a high degree of accuracy. So if we were to show accuracy on a board like we did before, something that is accurate would be around the center point of our board. So if we were trying to be accurate and correct, we're aiming for the center. We're pretty much hitting that target every single time. Now, this is compared to a set of data that is inaccurate. So maybe one of the ones that's up here in green. So certainly these marks are consistent and reliable like we talked about before, but they aren't hitting that center mark of the target board. Therefore, these would be inaccurate results or an inaccurate data set if we're going to use this analogy. Now moving on, this sort of means that there are 4 different combinations. Now we can have like the data sets say up here on the top, 2 sets, I'll use this, 2 sets that are both accurate. They're both centered around the middle part of the target, which is what we're aiming for. Consistent results where they're all jammed together in the center are considered to be reliable, whereas these ones that are a bit more spread out would be unreliable. Now down the bottom, we have a bunch of inaccurate results, results which don't actually hit the mark that we intended. But here we have a reliable set. We're consistently getting the same results. They're just not correct. And over here we have results that are both inaccurate and unreliable. They're not consistent and they're not actually hitting the mark. Just a way to sort of visualize what we've been talking about so far. Here's an interesting concept or an interesting experiment maybe to look like one that's completely theoretical, but a story that we can use to try and think about validity, reliability, and accuracy nonetheless. So a scientist set out to prove that cockroaches listened through their legs. He ripped off a cockroach's legs, sat it on the table, and clapped loudly over it. It did not move. He did it again, ripped off the legs, clapped, and it did not move. This process was repeated 10 more times, and every single time it yielded the same results. See, the scientist said, without its legs, the cockroach can't hear the clap and it doesn't move. Now I'm going to give you a moment to evaluate the validity, reliability, and accuracy of this experiment. Maybe pause the video. And once you've done that, you can then come and have a look at what our evaluation probably should look like. But I want you to come up with that yourself first. Now, here is a sample evaluation. So first off, our validity of the experiment would be considered to be invalid. Now, the idea is that the method stops the cockroaches from running, so we're not really testing our original aim if the cockroaches are no longer able to move, which is the entire thing the entire point of the experiment, the whole thing that we're trying to measure. For our reliability, we would say that it's reliable. We're getting consistent results for sure. Every single time a cockroach's legs is ripped off and the scientist claps over the top of it, what we're seeing is that those cockroaches aren't moving at all, and that happens every single time. And we've repeated the experiment enough to kind of see that that trend certainly occurs the whole way through. Now, for accuracy, though, we'd have to say it's inaccurate. It's very difficult to make a comment on accuracy when the design of the experiment is invalid, but a general rule is if the experiment's invalid, then we're probably not getting the correct results, so there is no result or conclusion that can really be made from any of our data because the experiment was invalid. Now, I hope this was helpful in you being able to start to reflect on validity, accuracy, and reliability, and I would look forward to seeing you in another Working Scientifically video.